Good morning, good afternoon, good evening to everybody that's joined us. Thank you for attending our Windows 11 Ready webinar focusing on Bluehill fracture today. I'm one of your hosts today. My name is Mark Overson. I'm from our Dynamic Systems Product Marketing Department. I'm the Product Marketing Manager. Alongside me today is Dr. Pete Bailey. He's our Principal Material Scientist. And also alongside me today is Dr. Nick Harrison, who is our Sales Support Engineer, primarily focused on OTC products, which is our accessories and software for after sales. A little bit of housekeeping today. So we will be recording this webinar for future posterity even. We will also be having a Q&A session at the end of this webinar. So we have a lovely little Q&A box as part of the software we have. Please type any questions you have in there at any time that you may have, and we will address them at the end during our Q&A session. Additionally, we're not planning to release the slides for this presentation to any of the attendees or registrants. However, if there is any specific information you would ask or require from us, then do not hesitate to contact your local salesperson or your local contact person. It'll basically get through to us and we'll look to help. We will be obviously providing some videos for availability at a later date as well, however. So, simple agenda for today in 3 steps mainly. First of all, I'll take everybody through what does Windows 10 end of support obsolescence mean. Then I'll be talking about how you can make your systems Windows 11 ready and the process behind that. And then for the centerpiece of our session today, we'll have a live demonstration of Bluehill fracture on an 8801 system here today. So, Windows 10 obsolescence, what does that mean? Periodically, Microsoft ends support for aging versions of their software. It's a normal procedure. It typically is a 5-year cycle, so this isn't something that is abnormal. It's quite normal. The reason we talk about this is that the impact that it has on their customers, i.e. Instron, is the same as it would have on yourselves as owners of Windows 10. We are unable to receive technical assistance, software updates, or security fixes on that platform from this state of end of support. This ultimately affects Instron's ability to support its software that isn't designed to work on Windows 11. It's also important to note that there are different versions of Windows 10. Some Instron supplied computers have Windows 10 Enterprise. There are 2 versions that are valid at the moment, LTSB and LTSC. Now, LTSB itself is going to be supported by Microsoft until this time, roughly next year in 2026. Windows 10 Enterprise LTSC will be supported until January the 9th, 2029, given the latest information we have. Now, it's important to note that many of our computers are supplied with Windows 10 Enterprise. However, the majority of our Dynamic Systems computers or products are supplied with Windows 10 Professional. And that's the version we are really focusing on today. And that will become unsupported from October the 14th, 2025. So ultimately, our aim is to, we're seeking to avoid any disruption to your Instron equipment to maximize your uptime. And we're recommending that you move to Windows 11 for various reasons that I'll talk about a little bit more detail later on. And the idea is that we're saying this early so that you can plan your upgrade path in the future. One key fact that I think is very, very important is that your existing system, your existing computer, just because the software is unsupported, it will continue to work. So your systems will not stop working. They will continue to work. However, your system could be at increased risk because, again, we will not be able to provide any Microsoft-based updates, security updates, bug fixes, or technical support on that piece. As well, over time, the software and hardware will gradually lose compatibility with your outdated Windows version. This includes Instron software and hardware as well. So, becoming Windows 11 ready and the process involved. Mainly, you need to verify your system and understand what your status is. We have many different systems out in the field of different ages, of different configurations. Some are new systems, some are very old systems. Some systems have been upgraded or retrofitted, depends on what you have. But ultimately, there are three parts that you really need to focus upon: the software, i.e., our proprietary Instron test software, like Bluehill Fracture; the computer, i.e., the PC and operating system, so Windows 10, Windows 7, Windows XP; and your hardware. So this includes your frame and controller, but also some accessories involved in there as well. Additionally, I just want to talk about our product lifecycle policy because this is important as to what can and can't be done. We have a four-phase lifecycle policy where phase one being in production systems and phase four being systems that are completely unsupported and out of production and what have you. So if your system is, or your software, your product is in phase one, it's in production. That means you receive our factory technical support, phone support, preventative maintenance and calibration is possible. Spare parts and repair are also available. Phase two, non-production, so we don't produce that product anymore, but we still seek to support it in the same way as we support phase one products. Phase three is what we call reasonable effort. So we do have limitations on what we can do with support. We still seek to provide preventative maintenance and calibration, but again, our parts, repair, and support does become limited because of these older systems might not just be compatible with newer features and newer functions. Phase four is where, unfortunately, we don't offer any support. Our support on the phone is very limited. These are very, very old systems typically. However, we are still providing preventative maintenance and calibration. However, our repair and spare parts are very limited and are typically not available. Examples of software that we're talking about: Bluehill Fracture is in phase one, so it's fine, it's Windows 11 ready. However, in phase two, we have other types of software: dadN, K1C, J1C, and E1820, just to name a few. Additionally, what we do offer is an additional service. So we offer a free lab health check. So we're also willing as a company to come to your site free of charge and assess your systems and help you understand where this lifecycle policy applies. Because you could have a frame that's in phase four, a controller that's maybe in phase two, and software in phase one. That is a potential opportunity. But understanding where each component is or where each part is in its lifecycle phase helps us explain how you move to become Windows 11 ready and get your systems up to date. Just a detailed slide here. I won't go through too much detail. However, it's clear to say if your system is equipped with the following products, then it's Windows 11 ready. And it's important to note here that we've got different types of software. We've also got accessories such as the AVE2, furnace controller, and Align Pro alignment products. In addition to that, we are releasing systems that are Windows 11 ready already. So if you've bought a new system, in essence, it will be receiving all of this stuff. So it's Windows 11 ready as of today. So focusing in on software compatibility a little bit here. Again, the understanding is to look to see what your software is and check your software. It's relatively easy to understand what software you have, and I'll get to that in a little bit. But ultimately, if your software is Wave Matrix 3, Bluehill Fracture, Bluehill Universal, they're all Windows 11 ready. If your system has Bluehill Universal on it, I think it's important to note that from a dynamic systems point of view, for fatigue, fracture, and all that testing, you need version 4.34. On a universal or static machine, you will require version 4.28 or newer. Now, we believe if you've got 4.28 on a dynamic machine, it will work fine. It's just we haven't tested it. It's as simple as that, really. Plus version 4.34 is available. For Wave Matrix 2, you'll require version 2.1 or newer for it to be compatible with Windows 11. However, I wish to be very clear that although this software will be compatible, it isn't going to be able to be supported with any updates because it is based upon a Windows 10 platform, okay, not Windows 11. And anything older than that, such as Wave Matrix, Bluehill 1, 2, or 3, they are phase 4. They're discontinued. They're not Windows 11 ready, and there's not really much we can do to get them ready for the latest version of Windows. So how do you check your software? So it's relatively simple. In every instance, you normally go to the home screen. For Bluehill Fracture in particular, you go to the home screen. You click on the Bluehill Fracture icon, as you can see described on the screen, and then you click on the yellow security key button section. And ultimately, within there, you will be able to find information on the version that you have, so that you can check your system. Okay. Again, if you're challenged with any of this, please do get in contact with us. That's absolutely fine. We're more than happy to help. Additionally, checking your computer, you can go onto any type of search browser nowadays, and you can type in, what is my system settings and functionality. It's very, very easy to check your operating system and PC. There are some methods described on the screen where you can go into settings, open your settings, click about and see basic information. Okay. But for further assistance, again, do not hesitate to contact us. Okay. The hardware check, the final piece. So ultimately, it's highly likely that your frame is more than okay to be compatible with the upgrades. There are some instances where that's not the case. However, the most important thing to focus on is your digital controller. So if you have an 8800 MT or newer, it is our newest, but a newer version, then it is likely to be compatible with Windows 11. Okay. If you have an older system like an 8800 Classic, it is unlikely that that's the case, and we do recommend that you contact us for further information. Again, upgrading the controller on your existing machines, it can be cost-effective way to give your systems a new lease of life and benefit from the latest material testing software. Again, it's important that Wave Matrix 3 or Bluehill Fracture might not be compatible with the system that you have now, but they have introduced many features over the years that improve productivity, efficiency, performance, and saving a lot of time. Again, if you wish to have support on checking your systems, we offer the free lab health check. You can also contact us directly. But one thing I am sure that my colleague, Mr. Harrison, opposite will love is if you can provide the serial number on your equipment. That will really, really help us understand exactly what you have, and it can expedite any inquiry that we have. Also, just finally on this page, we have product information on our website. So there is a data sheet on our controller, and there are data sheets on how you upgrade or retrofit your system to the latest software, hardware, and PC. So, without further ado, I'm going to hand you over to Dr. Pete Bailey, who will perform the Bluehill Fracture demonstration.
Great stuff. Thanks, Mark. I'll just come on camera there for a moment. Hi, folks. Hope you're having a good day. So just a few words about the software architecture in general before we get on to the demonstration. He says, hoping that the slide will advance, which is thinking about it. So one of the things in general about dynamic systems software is that we have console underpinning everything. That's giving you a window into what the controller is doing and allowing you to set up calibration and tuning and all those important fundamental things. And then we have our application software sitting alongside that or on top of it if you prefer, and actually dealing with what you want to do, what you want to measure, how you want to control your test, and all the application facing aspects. So last week, my colleagues gave you a little bit of a flavor of Wave Matrix 3, which is our general purpose fatigue and dynamic testing sequenced test software. Bluehill Universal is basically consistent with our static, our electromechanical test frames, and allowing you to do exactly the same basic tests, but on a dynamic load frame. Bluehill Fracture is our topic for today, and this is very much a application-specific software, really designed to get you very precise and robustly compliant measurements of fracture toughness, which are quite heavily controlled by the standards. But we'll see that in a minute. So to emphasize some of those aspects, the things that I think you should take away if you don't already know about Bluehill fracture is that there's a guided workflow for this quite complex test. It's rigorously compliant with the international standards about both the test and the analysis and how you validate the results. We've got some nice security about around method control and all those useful things for maintaining your accreditation if you're an accredited lab. And of course, we also have what we've been talking about just now, the IT compatibility issues, where you are moving from an old Windows system and needing to be with something more up to date. So in a moment, you'll see the Bluehill fracture home screen, and you'll see that there are 4 tiles here looking at your test roll, which gives you that guided workflow. When you want to come back and look at the analysis, look at the standards compliance, and investigate your test in detail, you look at the analysis. Security is giving us what I'll show you in a moment, some good control over who can access what. And a point about all dynamic software, in fact, all Instron software, press F1 for help. Almost wherever you are in any of our software, we have context help in all the modern software packages. Press F1 and it will tell you something related to the page or indeed even the field that you've got selected at the moment. So this is just a little bit about recap of what Mark was saying earlier. I'm actually going to go now from the slides into a demonstration, and then we'll have some questions and answers at the end. There's a Q&A box that you can click on and put those in the text to make sure we catch up with you. So I'm going to step away now and share the screen from the test computer. And hopefully you can now see that. That should be good. What you can see if you look at the background with me, and I will just pin my video so that you can see it reliably. You can see here I'm stood in front of our 8801 servo hydraulic test frame. There are standard hydraulic ambient grips on here, and then we have a clevis fixture, what we call piggyback, sat on top of there without the need to remove the grips, that will hold our routine CT, our compact tension specimen, which is fairly common for fracture toughness. So if you look at the screen now, I'm going to jump right into the workflow and then come back to some of the aspects of the method. Actually, before I do that, I will show you a point about the users. So I have access control enabled. If I click this button, I can, I've got only 2 users, the admin and the basic user. I'm going to log on as the basic user now. What you can see here is I've actually taken the method away. So what this basic user can do is they can only use existing methods that have been created, and they can review analyses. They can't create new methods, and they have limited access to edit the method in the test roll. So I'm just going to go back to my main view here. One other point Mark mentioned about finding your versions. If we click on that admin tab, the security is within that. We can enable and disable it. There's also information about not only Bluehill fracture, but it actually picks up your console firmware and your system ID for you as well, if you do need to access that. So doing what I said I was going to do and going into the test roll, I've got here some basic methods. They're shells that you can fill in and work as you go along. I've got some methods here as well, the tiles at the more to the right-hand side at the top, where these are specific methods I've created. Also, in the lower part of the screen, you can see I've got tests which are partly completed, and I'm going to continue. And that's what I'm going to do here. This specimen I have, in fact, partially pre-cracked to save some time, but you'll see what is happening there in a moment. And you can see what happens as we go through the webinar, go through the workflow in this webinar. So we start a test, and we obviously collect some details about the batch that we are going to attribute to it to, the specimen name or identification. We can also then decide which test standard we want to work to initially. And you can see there are a number of relevant test standards here. From there, we move on to starting to collect information about the test. Now, these are already filled in because I've already started this test. We have the material properties. So this is about your entire batch, and it's, broadly speaking, the nature of the material. So we're collecting some information about not only what you call it, but its composition, the form, the heat treatment, and the crack plane orientation, always important for wrought and rolled products. This is obviously not germane to the test itself, but what some people call specimen pedigree is really important to retain as part of the record. Perhaps less so if you're in an academic context and you've got a notebook that you're working with, but in the more commercial context, it's really valuable to keep this information bound together with your test data. Below that, you've got the straightforward tensile properties. Now, these actually come into some of the live calculation and certainly the validity checking calculations after we've done the test. Moving on from there, we need some specimen details. In this case, we have a CT, a compact tension specimen, and we need to check what those are. In this case, if you are actually doing the test live, then you might, before putting the specimen into the machine, you might take your calipers or your digital micrometer and collect those, type them in here. This is a fairly compact view of these parameters. It's trying to make things a bit more streamlined. I'll show you a little bit more about that in a minute. But for the moment, we'll move forward. We've got pre-cracking control already set up. This is a prerequisite for all fracture tests, that you do a pre-cracking, a fatigue pre-cracking, before you actually break your specimen. The point here is that you get a truly sharp crack down at the atomic level. Also, that you are through any mechanically distorted or deformed or worked material that's come from the specimen preparation process. So once we've done that, then we come to a start page. You can see this is saying that I'm going to resume pre-cracking because I had already started it yesterday. There's a little summary on the left-hand side of the page there, and you can see what it's going to do. Now, obviously, I need to put this specimen in, so I'm going to zoom in a bit, and hopefully you'll be able to see this reasonably well. I have my machine in setup mode with specimen protect enabled. I've already got this tuned. We're not going to talk about tuning today, but obviously it is important to machine control, and we have done webinars on that in the past, and there's some content on YouTube which you can view at your leisure, and I'm sure we will do some repeats in future. So I'm using the jog wheel on the handset to bring that down and put a little tiny bit of preload on there, using specimen protect to make sure it stays all at a sensible level. What I'm going to do is step around the back now, and hopefully you can see in the video me applying the clip gauge here. Please be careful with these They are robust, they're quite drop resistant, but do be kind to them. So my recommendation here is whether you put the specimen in the grips first or after, hook it onto one side of the knife edges and then just bring it gently up and hook it onto the other without squashing it down too tightly. And then a little gentle wiggle of that to make sure it is clipped in securely. So I'll zoom out again. And you can see me again. There we go. And we're now ready to start, although I do obviously need to switch the machine up to high power. So at this point, I'm going to click Start back on the software, if you look back there, and you will see that the machine is loading up and running a waveform again. You can see that just little live oscilloscope display of what's happening with the machine. And I'm sorry, I should have put my safety specs on before starting that. On the left-hand side, we've got at the top left a nice view of the force and displacement here, nice and linear and flat, which is where we should be. And below that, you've got a trend graph showing how crack length is increasing with time in this case. There's a little inflection at the top there where we've restarted, but it's fairly small. Obviously, I can change around these graphs, click on the pencil icon to reconfigure them, pick what's being shown. I don't have to have crack length. I could look at the force or the compliance or all sorts of things. More relevant is I've currently got it showing time. You might more usually expect it to be showing the number of cycles. So I can change all those as we're going along. You can see you've got a display during pre-cracking of what's happening on the right-hand side here. Also, now, in a case where you're doing a number of specimens, you really do want this to be consistent. So you're going to have your method set up and just use it as it is. However, that's not always the case. Certainly in a research context, you will regularly be having different materials, different specimens. And in other cases, if you come to a new material, new lab requirement where you've got different specimens of some sort, then the first one you do, you might not have it perfect. You might want to do some work to perfect your pre-cracking step. Now, in that case, you can make changes on the fly with these two buttons at the lower left. We can look at the compliance limits. So that's you can see on this graph next to it, that's the red section of the curve is being fitted. You don't always want to fit absolutely all of it to avoid a little bit of noise at the top and bottom. And in some materials, there's what's called crack closure forces. Perhaps more important is this one, where we look at what the peak stress intensity is, whether you're using constant or decreasing delta K, and some various other options. Now, this is fairly close to our target crack length, but I'm going to leave that running for a few minutes while I talk about some other points. Now, in order to do that, I've got another instance of Bluehill fracture running. This is something that's a nice option, allowing you to run a test, but also look at preparing or checking methods, reevaluating or analyzing other tests that have already run. But with all that good safety that there's this second instance cannot get into run mode and get things all confused and cause any safety issues. So while that pre-cracking is running, I'm going to talk a little bit about the method and optimization. So here we are looking at the method role. We're going to work on or create new methods. There are 4 types of methods, 4 categories within Bluehill fracture. Brittle fracture, so this is purely linear elastic behavior until sudden failure, which is what we're going to do today with this aluminium specimen. It's quite a good test for a lot of structural alloys like aluminium, titanium alloys, some nickel-based alloys, but not all. Anyway, it's quite common for structures work. Below that, we've got fatigue crack growth rate, and this is really where we're going to look at crack growth as a function of stress intensity range. That's not fracture toughness per se, but fatigue crack growth. Next to that, we have what's broadly labeled ductile fracture, where we're taking that from some of the language used in ASTM. More properly, we should call it elastic plastic fracture. There's some ductility is the point. There's some plastic deformation and more gradual tearing that occurs as the material fails. Finally, above that, we have DCPD, that is electrically based crack length measurement during a more ductile fracture process, a more elastic plastic process. This is really useful for high temperature work, where sometimes compliance, that is using a CMOD gauge like I am here, is less helpful or achievable. But what I'm going to do is show you an example with, this is the method which the currently running test is based on. This is a demonstration for ASTM E399. And so you can see here across the ribbon at the top, we've got the different groups. We work across the ribbon and then down the sub-menus as you go. So within a method, we can leave as many or as few things blank, or as many or as few things filled in as we want. In this case, I already filled in some tensile properties for it. For the material, we look at the specimen dimensions and the geometry, importantly. So there are a lot more dimensions here than you saw on the test screen just now, and I'll show you how and why that is in a moment. Before I do that, I'll just address the matter of the types of geometry. We can support all of the different specimen types that are supported by the standard that's selected. Now, for E399, that means obviously that you've got straight notch CT, you've got bend specimens like this, you've got disc-shaped specimens and arc-shaped specimens. But if I hop back and select, let's say, the ISO standard 12135, we don't have the circular specimens or the arc specimens. So those are automatically restricted to what's supported by the standard. I mentioned about streamlining and preparation there. That's within, if we look briefly, we can set up the pre-cracking and the measurements and the test control, all of those things with a little bit of guidance. But then on the right-hand end of the ribbon here, we have test workflow. And if you're doing maybe one specimen, two specimens, and everyone is unique, then this might not matter to you. But for batches, it's really worthwhile optimization. What you can see here is that I've got a pop-up from console saying the application has stopped, and we're flashing blue on console here. That's because over on the other version, my pre-cracking has automatically got to its target, and it's paused there. So I'll come back to that in a moment. Before I go there, I'll finish talking about the method and optimization. So what we can do here, you can see a little cartoon of the test sequence, again, above the text here. But if let's say we always perform the same pre-cracking routine, we're always going to a target proportional crack length, we're always using a constant delta K for a batch, we don't need to show those control settings. And perhaps likewise the main test control settings. And you can see as I switch those toggles off, my cartoon shows that I've got fewer screens to stop at. So it just makes the process a little bit cleaner and simpler. Now, if I pick on one of these screens, I can also check on what's shown here. And what you can see in this one is that I'm only showing these properties that I want to show. I can also decide whether I want or not I want to permit the operator to change them. So I might say this method is only for CT specimens, make it view only access. Or if I want them to allow other specimens, I can. Equally, I can add and take things away. So I can collect things like what's the total height of the specimen, what's the hole diameter. But they don't take part in the calculations. They're not critical, and they're probably not that relevant for you to collect in a routine setup. But you have some control there. You can optimize it. The last thing I'm going to say at this point, before I move on, is about reports. So what we have here is there are report templates in the same way as there are method templates, and we can connect the two together however we wish. This is fairly configurable. You get a little preview of what it will create here. And we can change around what the order is, resequence things, and your view updates. And we can change things like, well, I want that graph to be a bit smaller, so I can change how big it is on there. And so all of this can be saved separately and linked to the method, as I say. So I'm going to exit out of there. No, I'm not going to save changes to this method or to the report. And I'm going to go back to my other version of the software. Now here you can see I had set a target crack length of 25 millimeters, and the moment the system estimates it's got to that, it stops and it says our target crack length has been reached. So I'm going to say OK to that, and I can then move on to a summary. So what we can see here is a little summary graph, and you can see on the right-hand side that these key data points have been filled in for you. Now, this will happen automatically, even if you actually choose not to record anything from your pre-cracking trend data or tracking data, because the system knows what all of the supported standards need in terms of validity checking, and so it will collect those data points as we go along and fill them in automatically for you. So I'm going to move on to the main test control. Very simple here. Obviously, if we were doing a ductile test, a J1C test, that's a lot more complicated, and there are more parameters here. We can look at an example of an analysis of that in a couple of minutes' time. So from there, we move on to another test-ready page. For K1C, where it's a very straightforward test, we actually do have an option to automate this, and it will automatically get to the end of pre-cracking, then run the main test. Most people choose to just have that checkpoint of the human inspecting things first, though. Little summary of what it's going to do on the left-hand side here, and then I'm going to click Start, and we're going to pull the specimen apart as we go. So here we are, graph automatically scaling as we go up, little bit of a toe at the bottom end there, and we're going up nice and linear. A couple more kilonewtons and we're likely to see it going. What you probably can't hear through my microphone is that going snick repeatedly as it drops down. So that's automatically stopped. We've gone past 50% drop in the peak force, and the system has stopped automatically. What I'm going to do is now I can see what's happening there. I'm going to move forward into the analysis stage. So here, before we can actually run the analysis, we need some crack fronts. We need to know how long that initial pre-crack was. So what I'm going to do is we're already in specimen protect roll automatically. I'm going to remove my clip gauge, my extensometer, and what you might be able to see is that the specimen is not broken right through, so I do need to pull that apart. In order to do that, if you're watching the video for a moment, I'm going to use the handset. Now, I need full power to do this, but obviously I'm locked out. what I can do is I can go to two-handed control. I can bring control across to the handset here rather than computer, and then pressing my thumb on here and holding this so that my hands are both occupied and can't get in the test area, I can then jog with full power and pull this, having first disabled specimen protect, of course, pull this apart into two pieces. Drop back into specimen protect and into setup mode. That's low power if you prefer. And take my specimen out. Coming across the camera here, you can see, hopefully this is just about in focus still, you can see this typical nice symmetric crack actually, nice and straight. What we will do is we will measure at 5 points across the width for E399. For all other fracture standards, it's actually 9 points. And then we will enter those on our screen here. Now, I'm not actually going to do that. I'm going to enter some arbitrary values here for the sake of time. But what the system will do with this is, as part of the validity checks that are required by the standard, it compares these, it takes an average, it also compares these and makes various metrics on how straight the crack is. And if that was unlike that, in fact, I have one from one I made earlier, as it were, you can see this is a very asymmetric crack. This would tell us that it was machine loaded with a degree of misalignment in the machine, and that would not be permitted as a valid test. The other thing that we should mark here is that the crack plane, that's the direction it's proceeded in, is nice and in line. It has gone across rather than steering off to one side. In case you wonder, that is something that happens with certain orientations of rolled material. It will diverge almost off at 90 degrees. So I can now move forward to the analysis, and as if by magic, here are some lovely, nice-looking results. We've got our plot here with the construction lines marked on it. You can see a provisional result. You can see we've failed a validity check here. Now, in this case, I was perhaps a bit optimistic during my pre-cracking about how high the final KQ value, the final fracture toughness would be. The rules are that you need to stay below 60% of that in the final stage of pre-cracking. So that is a certain disadvantage. You need a little bit of prior knowledge about your test. An important point to mention here is that we are using an automatic fitting algorithm for finding this linear slope. So for Instron software, the automatic mode here for Instron Bluehill fracture, it is the ASTM algorithm, the recommended method, as standardized in E3076. So actually we, myself and my colleagues at Instron have been involved, were involved with the development of that, participated in some round robins very early on. And as far as, to my knowledge, Bluehill fracture is the only commercially available software which uses that automated fitting method exactly to the standard, and which is also recommended but not required by E399. In terms of why you should care, it is about creating more reproducible results. Now, it's a little bit, it can be a little bit arduous to code. It's a very data-heavy method, but there are free versions out there to analysis tools which are available, produced by various people if you're doing your own analysis and you want to compare with ours. Again, back to why you should care. I was recently, last year, I participated and in fact coordinated a study for ASTM committee where we looked at the analysis of a set of 15 data sets. These were produced 10 years ago and from various sources. So we gave the same exact raw data to 12 different labs and asked them to analyze it according to the standards. Now, what happens if you use the automated fitting algorithm is that you get much better, more reproducible determination. So the scatter in the results was up to 10 times greater from the same data set if you use just visual traditional methods as compared with using this algorithm. Anyway, that's enough about perhaps my hobby horse of reproducible results and repeatable analysis. Let's talk a little bit about what happens next. So if I was to finish this specimen, I could automatically generate a PDF report or plain text, if that's your preference for your storage system. And I could either start a new test exactly the same as the one I've done, or return to the test homepage. So that's a nice way to restart and just loop round if you're doing a batch of specimens. I'm not going to do that. I'm going to have a little look at the analysis. So let's go back to the home screen and click on the analysis tile here. Top of the list is my most recent specimen. So I'm going to open that. I can dig into those validities. So here, rather than just seeing the summary, I can find all of the clauses, a little description of each, and exactly what we measured during the test. And you look at this one that we failed here, we were pretty darn close. The absolute maximum that happened, including a little bit of variation during the test, 12.09 MPa root meters, and we were allowed 12.006. So we were very close. I cut things a little too fine. The other thing that we can do within this role is to choose to reanalyze. We've got our data now, but what if we want to report a result according to the ISO standard? Oh, well, I can do that. I can just select it from my General tab, go back to my results page. Now, you can see what the problem is here. It's telling you very clearly we need some more crack front measurements because we only did 5 for E399. Now I can go back and re-enter those, and now the system will be satisfied, and I will have my results, which are basically the same for K1C, but ISO applies some slightly different validity checks, so it's failed for different reasons. I think that's really what I want to say about the K1C test for our demonstration. What I will very briefly show you is an example test. This is some idealized data provided by ASTM alongside E1820 standard. But just to give you a little illustration of what the things look like when you determine J1C. So very much the same sort of scheme here with results and validities. The method is obviously more complex because we have to do this with a series of unloading sequences. So you can see the test control page is much more complicated, but pre-cracking and specimen details are all exactly the same. And obviously, if you want to see what's happening with those analyses, we've got a table of data, and you can see what's happening with the raw data as a continuous data graph. So I think that's a slightly different sequence to what I did earlier on, but covering all the same things. I'm going to wrap up the demonstration there, and I suspect there are probably some questions to go now. So, Mark, back over to you, and we'll see what's coming on the questions.
Thank you, Pete. Much appreciated for that demonstration. I hope that was wonderful and valuable to everybody on the webinar. We're just going to go for a little Q&A session. I've got a few here, actually, I've got quite a few here, but we've got a little bit of time, so let's do that for now. Okay, I'll open things up to everybody. Let's start off with an easy one. Um, can you perform static tests on a dynamic machine? Who'd like to take this one?
Oh, shall I have that one? Yes, yes is the answer. And in fact, what that's to some extent what you've seen with the fracture toughness itself. But more to the point is, as I was mentioning earlier, we also support Bluehill Universal, which those of you who have Instron static test, electromechanical machines will be familiar with that. That is what you use there. Basically, we can install that here. It will work and behave exactly the same, but you're just using the hardware of, let's say, a hydraulic machine rather than a ball screw driven one. Reasonable answer there, Mark?
Yeah, I think so. Wonderful. Another one for you, I think, Dr. P. What is setup low power mode typically used for?
Okay, so that's great. That's maybe not software related, but system related in terms of how our system works. So setup we have off, obviously. We have low setup and low power, then high power or run mode. So setup mode gives us some more safety in terms of restricted machine movement rate. So that brings us into all being compliant with the Machinery Directive in Europe, which regulates how fast things can move when an operator is setting things up and has their hands close to the test area in our case. It also automatically gives you the options of specimen protect, keeps you safe, and restricts the power applied to and to some extent the force applied to the specimen. It's a way of in kind of locking out where you're operating and being a bit safer at the as the person with their hands in the test area. So I
Okay.
think hopefully that's clear.
Yep, wonderful. Thank you. One for Dr. Nick here. Can I use dadN on Windows 10?
On Windows 10, um, you can, but having just gone through the last hour or so of this webinar talking about Windows 11 readiness and compatibility, and indeed Peter's excellent demonstration of Bluehill fracture, why would you? Uh, Basically, the reason for that is as well we've integrated a lot of the older fracture mechanics modules, so dadN, K1C, J1C into Bluehill fracture. So it's combined all of these test modes, and we haven't updated dadN for over 7 years now. So if there's probably going to be a lot more advanced techniques that have been applied into dadN as a result of being integrated into Bluehill fracture. So yeah, um, yeah, we suggest going to Bluehill fracture in that case for dadN testing.
And I think if you really are interested in particularly in crack growth testing, that's a great topic for another day. It's much more depth and breadth there. We'd love to talk to you and have a more detailed conversation. So please get in touch if you want to.
Okay, thank you. Next question. Okay. Does this software use the latest version of E399? I think one for you, Pete, please.
Yes, absolutely, and absolutely the right question. While for some people, you'll be well aware that there are minimal technical changes in many revisions, and the basic calculation, as you see, has not changed. There are a lot of updates, small updates. Sometimes they're about validity criteria. Sometimes there are other pieces in the text. But one of the biggest selling points for many of our customers is that we're rigorously standards compliant. And that means you need to be able to prove it. You're paying us effectively not just to do the calculations, but to make sure that you're compliant around everything. You're picking out all of those validity checks accurately, and pulling that all together for you. So with that, obviously, you do need, if that's important to you, you also need to be on top of the latest standard. So one of our undertakings is that we update our software, and the new version will be released within, or more to the point, before 6 months from when it's published. Now, that's really important for anyone who's not aware. Accredited test labs generally need to implement a new version of the standard within 6 months of it being published. So we will make that available and get it out to you sooner than that, provided you request it. We do try to make that available easily. There is obviously a small fee for that, but we have a route to that, which possibly Nick would like to talk about in terms of just the standards upgrades.
Thanks, Pete. Just where of the time at the moment? Like room for one more before we just close off. I think one for Nick in a second. Are there any library updates available?
Yeah, that leads quite nicely on from what Peter was just talking about with standards and the library that is backing Bluehill Fracture. We have updates available, and Mark and the team have done a wonderful job of keeping the web page for all of the standards library up to date. So if you go into your internet web browser and type in Instron Bluehill Fracture Standards Library, it will bring you to a really detailed web page of the current standards, and you can see which versions have been updated, or which versions of Bluehill Fracture have been updated, and what standards that's incorporated. So yeah, easy enough to update. Just get in contact with your local sales account rep, and we'll be happy to help from there.
Thanks, Nick. Thanks, Pete. Right, let's move on to the next and just wrap up. Okay, so just to cover off something Pete mentioned earlier. So we also have a new white paper available, how standard is a determination according to ASTM E399. Great white paper. Download it from our website. The link is on the screen there at the bottom at info.instron.com. Discover our K1C white paper. Or again, just type into our search box and you'll be able to find it as well on our website. Okay, but thoroughly recommend you download that free white paper around E399.
Yeah, thanks, Mark. I appreciate that. And I would also point out that that's us making it easy to find. It is a refereed journal paper that's literally in publication now through ASTM, STP. So hopefully it's useful to folks out there.
Wonderful, thank you. Okay.
I think we're out of time, Mark.
Almost there. So I'm just
there we go. He's getting into the last slide.
So yeah, so just to sum up, so there's a three-stage process with getting your system Windows 11 ready. Again, Windows 10 Professional is becoming obsolete as of October this month, in a week or so. So yeah, be mindful about that. For other versions of Enterprise, that's at a later date. To become Windows 11 ready, there's 3 stages to that. You need to check your software, review your PC and its operating system, and ultimately as well your hardware. So your frame should be fine, but do check that as well. But your digital controller and any accessories that you have on that. And again, if any of this is unknown or challenging, we're always here to help. So please contact us via our webpage. In the top right-hand corner, there's a little button to contact, or contact your local salesperson. They'll be happy to help. Okay. So at this point, without further ado, I just want to say thank you to everybody for their time today, for everybody that's joined us. Have a wonderful day. Thank you.